Hello friends, welcome to Maths Nerd.
Today, we will solve some complex problems based on quadratic equations. The question is x plus 1 equals 6 divided by x. This is not the standard form of a quadratic equation and we have to convert it into the standard form, that is ax squared plus bx plus c equals 0. So for that, we'll multiply both sides of this equation by x. So we will get x times whole of x plus 1 equals 6, since x on the RHS gets cancelled. So x times x is x squared, x times 1 is x equals 6. Now to get 0 on the right hand side, we'll subtract 6 from both sides of this equation. So we'll get x squared plus x minus 6 equals 0. And we have got this as the standard form. Now here we'll solve all questions using the factorization method. So for that we'll write here 1 and 1, and 1 into minus 6 gives minus 6. Now we have to find two factors of minus 6 whose sum will give us to 1. So what are two factors of minus 6 whose sum will give us to 1? So they can be minus 2 and 3, because minus 2 into 3 is minus 6 and minus 2 plus 3 is 1. So we'll continue this equation here. It is x squared minus 2x plus 3x minus 6 equals 0. So that is, now we'll take x common in these two terms. So x times x minus 2. Then we'll take 3 common in these two terms, that is the last two. So that is equal to 0. Now we'll take this x minus 2 common in this full LHS. So it is x minus 2 times x plus 3 equals 0. So any number multiplied by 0 is 0. So either of these can be 0. X minus 2 is equal to 0, or x plus 3 is equal to 0. So x equals 0 plus 2, or x equals 0 minus 3. X equals 2 or x equals minus 3. And we have solved this question. Let's see one more example. So the question is 1 upon x plus 1 upon x plus 1 equals 11 upon 30. And we have to get this equation into the standard form ax squared plus bx plus c equals 0. So for that, first we'll add these two fractions by multiplying the numerator and denominator of the first fraction by x plus 1. So we'll get x plus 1 divided by x times x plus 1 plus, and the second fraction will multiply both numerator and denominator by x. So it will be x upon x times x plus 1. So that is equal to 11 upon 30. And then since the denominator is same, we can add these fractions. X plus 1 plus x upon x times x plus 1 whole equals 11 upon 30. So that will get us to 2x plus 1 upon x into x is x squared, and x into 1 is x equals 11 upon 30. Now we'll cross multiply this equation to get it in the standard form. For that we'll multiply this with this and this with this. So 11 times x squared plus x equals 30 times 2x plus 1. So that is 11x squared plus 11x equals 60x plus 30. Now we'll subtract 60x and 30 from both sides so that the right hand side is left with 0. So it is 11x squared plus 11x minus 60x minus 30 is equal to 0, and then we'll get it 11x minus 60x is minus 49x, so 11x squared minus 49x minus 30 equals 0. Now let me continue it on the other side. We have got this into the standard form, so we'll solve it using the factorization method. So that is, first we'll multiply 11 into minus 30, so that is minus 330. Now which two factors of minus 330 give a sum of minus 49? They can be minus 55 and 6. This is negative 55. So let us write it as 11x squared minus 55x plus 6x and minus 30 is equal to 0. So that is 11x as a common times x minus 5 plus 6 as a common, x minus 5 equals 0. So x minus 5 whole as a common, so that is x minus 5 times 11x plus 6 equals 0. So either x minus 5 is equal to 0 or 11x plus 6 equals 0. Let us continue this on the next page. So x minus 5 equals 0 or 11x plus 6 equals 0. So x is equal to 0 plus 5 or 11x equals minus 6. So x is equal to 5 or x is equal to minus 6 upon 11. And we have solved this one too. Another question coming up. Here the question is 2 divided by 3x is equal to x minus 1 whole divided by 2x minus 1 whole. So for this, since we don't have any two fractions on either side, we'll directly cross multiply. So 3x will be multiplied to x minus 1 and 2x minus 1 will be multiplied to 2. Let's see this in action. 3x times x minus 1 equals 2 times 2x minus 1. So that is 3x into x, so that is 3x squared minus 3x into 1, so that is 3x is equal to 2 into 2x, that is 4x, and 2 into 1, 2. So we'll subtract 4x from both sides and add 2 to both sides so that this right hand side is equal to 0. So 3x squared minus 3x minus 4x plus 2 is equal to 0. So minus 3x and minus 4x is minus 7x. And we have got this in our standard form, ax squared plus bx plus c equals 0. And now we'll factorize it. For that, we'll multiply 3 into 2, so that is 3 into 2, 6. Now we want two factors of 6 whose sum will be minus 7, that is this thing. So the two factors of 6 can be minus 6 and minus 1, because minus 6 into minus 1 will give us positive 6, and minus 6 plus negative 1 will give us minus 7. So this thing can be written as 3x squared minus 6x minus x plus 2 equals 0. So taking 3x common in the first two terms, x minus 2, and taking minus 1 as common in the last two terms, we'll get again x minus 2. So taking x minus 2 common in the left hand side, we'll get x minus 2 times 3x minus 1 equals 0. So either of them can be 0, because 0 multiplied by any number is 0. So we'll write x minus 2 equals 0, or 3x minus 1 equals 0. So x can be 0 plus 2, or 3x can be 1. So x is equal to 2, or x is equal to 1 upon 3. And we have solved this question also. Let's solve the last one. Here we have got the question as x divided by x minus 1 whole plus x minus 1 whole divided by x is equal to 5 upon 2. And we'll again convert this equation in the form of ax squared plus bx plus c equals 0. So for that, first we'll add these fractions. So we'll multiply the first fractions, numerator and denominator, by x. So that is x squared divided by x times x minus 1 plus, and then we'll multiply both numerator and denominator of the second fraction by x minus 1. So it is x minus 1 squared whole squared divided by x times x minus 1 equals 5 upon 2. So we'll get x squared, and we can add these fractions since both denominators are equal. So x squared plus x minus 1 whole squared we can find using a minus b whole squared law. So that is x squared plus 1 minus 2x, and this is divided by x times x is x squared, and x times 1 is 1. Sorry, x times 1 is x, and then is equal to 5 upon 2. And then we'll cross multiply, or first we can simplify the numerator. So it is 2x squared minus 2x plus 1, all divided by x squared minus x equals 5 upon 2 again. So now we'll cross multiply. 2 will be multiplied by the numerator of this, and 5 will be multiplied by the denominator of this fraction. So let me write 2 times 2x squared minus 2x plus 1 equals 5 times x squared minus x. So it is 2 times 2x squared is 4x squared minus 2 times 2x is 4x plus 2 times 1 is 2 equals 5 times x squared is 5x squared, and then 5 times x is 5x. Written this on a new page, and then we can switch the sides, that is 5x squared minus 5x equals 4x squared minus 4x plus 2. So we'll subtract 4x squared, add 4x and subtract 2 from both sides so that the right hand side is 0. So 5x squared minus 5x minus 4x plus 4 minus 4x squared plus 4x minus 2 is equal to 0. And then 5x squared minus 4x squared is x squared minus 5x plus 4x is minus x, and we have got minus 2 alone, so this is equal to 0. Now we can write 1 here so that we are able to factorize it. So that is 1 into minus 2, we'll get minus 2, and then we'll find two factors of minus 2 whose sum will be minus 1. So they can be 1 and minus 2. So we'll write this thing here in the form of 1x squared plus x minus 2x and minus 2 equals 0. So we can take x as a common, so it will be x plus 1 in the brackets, and we can take minus 2 as a common, and here also x plus 1 equals 0. So taking x plus 1 as a common, we'll get x plus 1 multiplied by x minus 2 equals 0. So either of these can be 0. X plus 1 equals 0 or x minus 2 equals 0. So x equals 0 plus 1, or x equals, that is 0 minus 1, I'm sorry, and we get 0 plus 2, so that is x equals minus 1 or x equals 2. And we have solved this question.
Feel free to ask your doubts in the comments. Thank you for watching this video. Please like and share this video, and don't forget to subscribe my channel for more videos.